Hello viewers, in today's class we are going to solve one important integral which involves greatest integer function, right? So let us solve this definite integral where the limits are from log 2 to log 5 and the greatest integer e raised to x minus 1. So here e is the exponential number and this ln is the natural log, right? So let us start. So let us first denote this integral by I, and here we'll make use of the substitution method to solve this integral, right? So let us substitute t is equal to e raised to x minus 1. So now t is equal to e raised to x minus 1. So dt is equal to e raised to x dx, right? Now from this relation we have e raised to x is equal to t plus 1, right? So now here e raised to x can be replaced by t plus 1. So dt is equal to t plus 1 dx, and dx is equal to dt over t plus 1, right? Okay, now here we have changed the variable x to t. So let us change the limits. So here when x is equal to log 2, then the value of t is equal to e raised to log 2 minus 1, right? Now we know the important relation which says that e raised to log of say p is equal to p, right? So here we'll make use of this result. So here we have e raised to log 2 minus 1. So the value of p is 2 here. So here we have 2 minus 1. So this is 1, right? So when x is log 2, then the value of t is 1, right? Similarly, when x is equal to a log of 5, then the value of t is equal to e raised to log 5 minus 1, and again using this result, e raised to log 5 is equal to 5 minus 1. So here we have 4, right? So now this integral I, this reduces to I is equal to integral from t is equal to 1 to t is equal to 4, and here we have greatest integer e raised to x minus 1. So e raised to x minus 1 can be replaced by t. So here we have greatest integer t, and for dx we can write dt over t plus 1, right? So now this integral is equal to from 1 to 4, and here we have greatest integer t divided by t plus 1 and dt. Now viewers, here let us take the help of number line. So here we have t is equal to 1, and here we have t is equal to 4, and between 1 and 4 we have two integers, namely 2 and 3, right? So now let us split this integral into three integrals, I1, I2 and I3, right? So we can write I is equal to I1 plus I2 plus I3, and I1 is from 1 to 2. So here we have the integral from 1 to 2, greatest integer t over t plus 1 dt, and I2 is from 2 to 3. So here we have 2 to 3, greatest integer t over t plus 1 dt, and For I3 we have the integral from 3 to 4. So here we have the integral from 3 to 4 greatest integer t over t plus 1 dt, right? So here what we have done so far, we have this integral, we have changed the variable x to t, and we have got this integral from t is equal to 1 to 4 greatest integer t over t plus 1 dt, and we have split this integral I into three integrals, first from 1 to 2, second is from 2 to 3, and third is from 3 to 4. Now we have to evaluate these three integrals. Now let us write the value of this greatest integer t between these three intervals. First is from 1 to 2. So when t lies between 1 and 2, then the value of greatest integer t is 1, and when t lies between 2 and 3, the value of greatest integer t is 2, and when t lies between 3 and 4, the value of greatest integer t is 3, right? So now these three integrals can be rewritten as, so I1 is from 1 to 2, and the value of greatest integer t is 1 because t lies between 1 and 2. So here we have 1, and in the denominator we have t plus 1, and here we have dt, and I2 is from 2 to 3, and when t lies between 2 and 3, the value of greatest integer t is 2. So here we have 2 over t plus 1 dt, and when t lies between 3 and 4, then the value of greatest integer t is 3, and in the denominator we have t plus 1, right? Okay, so now these three integrals are reduced to these three integrals, and now here we can simply integrate these functions, and here we'll make use of the result that integral of dx over x plus a is equal to a log of x plus a, right? So here we have the variable t, and for a we have 1. So now the integral of 1 over t plus 1 is equal to log of t plus 1, and the limits are from 1 to 2. Then we have here again taking this 2 outside this integral, the integral of 1 over t plus 1 is log of t plus 1, and the limits are from 2 to 3, and here we have 3, taking this 3 outside this integral, we have 1 over t plus 1, and the integral of 1 over t plus 1 is t plus 1, and here the limits are from 3 to 4, right? Okay, so now we can simply substitute the limits here, and we'll take the difference. So now substituting the limits here, we'll have log of 2 plus 1 3 minus log of 1 plus 1 2. So we have log of 2, right? So for this we have log of 3 minus log of 2, then we'll have 2 times, here we'll have t is equal to 3, so 3 plus 1 is 4. So here we have log of 4 minus log of 3, because t is 2 here, so 2 plus 1 is 3. Then we have here plus 3, and the value of t is 4. So here we have 4 plus 1 5 minus, and t is equal to 3, so 3 plus 1 4, right? So substituting the limits, we have got this expression. Now we can easily simplify this expression. So now making use of the properties of log, log 3 minus log 2 can be written as log of 3 over 2, and here we have 2 times of log 4 over 3, and here we have 3 times log of 5 over 4, right? So here we have made use of the property that log of m minus log of n is equal to log of m over n, right? So now this is log of 3 over 2, and here we have log of 16 over 9, and here we have log of 125 over 64, right? Again, here we have used that log of say m log n is equal to log of n raised to m, right? So here we have 4 over 3 raised to 2, that is 16 over 9, and here we have 5 over 4 raised to 3, so that is 125 over 64, right? Now again using the property of log, so we have log m plus log n plus log say p is equal to log m times n times p, right? So here 3 over 2 can be taken as m, and 16 over 9 can be taken as n, and 125 over 64 can be taken as p. So now we have log of 3 over 2 multiplied 16 over 9 multiplied 125 over 64, right? Now cancelling out the terms, so here we have 16 4s are 64, and here we have 3 3s are 9, so we are left with a log of 125 over 24, right? So the value of this integral is log of 125 over 24. We can also express this result as log of 125 minus log of 24 by making use of this property.